I'm Darcy again.
And I'm Kyle.
Today we have a guest with us. We have Adam Smith with Millennium Plastics. He is the president over there. Tell us what you do at Millennium Plastics.
Yeah, hi. Thanks, guys. Glad to be part of the podcast. So Millennium Plastics, we're in the injection molding industry, primarily targeting automotive, although, going outside into industrial, some medical and things like that are always options as well. Just my experiences in my career has been with the automotive industry. So that's where we focus. We focus on tight tolerance, hard, difficult to mold, engineering grade plastics, and that's kind of our niche, high volume, tight tolerance molding.
In today's global economy, quality matters. Benjamin Franklin once quipped, "The bitterness of poor quality remains long after the sweetness of low price is forgotten." Quality Matters is here to talk about all things quality. So whether you're looking to improve your business, getting ready for an audit, or dealing with failed inspections, tune in, check us out, then get back to doing work that matters.
Oh, that's neat. Okay, so I'm going to have to pause. My role in the podcast is to ask questions about things I don't understand so that anybody listening understands what's being talked about. What is injection molding?
Injection molding, if you pick up just about any plastic part on your desk in your household, it's likely that it's injection molded. So what injection molding is you're taking plastic that usually comes in the form of pellets about the half the size of like a pea, and it goes through a heating process, which is called the barrel and the screw, or some of the injection molding components. And then it takes that molten plastic and injects it into a mold that forms it into the parts that you see with everyday use. I mean, think about your controllers for your TVs, and those components are usually injection molding. But yeah, so that's really it. If you think a lot of your everyday use items and a lot of the plastic components that you see inside cars, it's usually injection molded.
Okay, so just like what it sounds.
Yes, it is.
Yeah, yep.
And then you mentioned a tight tolerance, which I'm sure Kyle is going to want to investigate a little more.
Yeah, something I this is a world that I've not had a whole lot of experience with myself, and I'm more used to coming from a welding and fabrication type world. So it's pretty obvious. You can put a dial caliper on it. You can put a micrometer on it. You can check the tolerances on these things and make sure you're still working. How does that work with injection molding? Do you have to worry about the molds deforming and things of that nature?
Yeah, plastics it's a little bit of a different animal, especially when you're considering and talking about tight tolerance stuff, because the actual process of molding becomes really, really important. If you're making parts for everyday use, like your covers for your, remote controls and things like that, that's not going to, generally speaking, be tight tolerance. There's fit, form, and function that needs to take place for those components to work and assemble. But when I'm talking tight tolerance, I'm talking about tolerances that end up being, plus or minus 0.03 millimeters. I mean, we're talking really, really tight. We're, thousandths of inch if you're dealing with English, or tens of thousands. And that's an interesting thing with the automotive world too. Most of the automotive world it deals with metric instead of English units. Yeah. But the mold, you're talking about the steel, that becomes very important. You need to hit certain shrink rates. So it kind of all starts with the mold. If you don't have a mold that's capable from cavity to cavity, because in injection molding, every time the mold opens and shuts, and especially in high tolerance and high volume, you're not only making one part every time that happens. You're making 16, 32, 64, 128. You're making a lot of parts every time that mold opens and shuts. And the goal is that every single one of those parts are exactly the same. So if you can't make the steel measure exactly the same, if you're not dealing with a tool shop that's capable of reaching those tight tolerances on the steel itself, your plastic part's never going to be the same. So it all starts there.
So do y'all have to have special alloys for this is just fascinating to me. Like, you have special alloys for the molds, or, I assume just standard carbon steel is not going to work well for you here.
Yeah, I can't just use P20 steel. for high volume, you're using S7 or H13 steels. You can get into alloys, and you can get into some really neat things with different alloys, depending on what your goal is to achieve. But really comes down to application specific, the type of plastic material you're using. If it's really an abrasive material, you start getting into coating the tool steel. For real abrasive materials that are glass filled and that runs high volume, a lot of times we will double coat it with a different colored coating, so you never get back down to virgin steel before you realize that hey, this coating's wearing off and we need to recoat to where we can protect the virgin steel, so we don't have to weld or replace cavities and cores if it's beyond repair. Interesting. But that's the world for high volume. It gets into, a lot of people can buy an injection molding machine and get a tool built just about anywhere. There's lots of tool shops around all over the world, but without a quality tool up front and a really robust maintenance plan, the quality of that product can deteriorate over time very quickly.
Interesting. Well, these coatings, how much does that affect the final tolerance of the part that you're working with?
It depends on the coating. A lot of coatings, especially for ones that are for abrasive resistance, can go on really, really thin to where it's almost minuscule. You won't see it at all. There's other coatings and platings you can use that add on a certain degree of thickness, and it's not an exact science. But it all has to do with, how long the steel itself is, in the process of being plated, which is usually a dip process into, a bath of that material for a certain amount of time that will add to it. So it varies on the coating, I guess, really is the short answer. But the more in-depth answer, I suppose, is some of that stuff you can use coatings and platings and things of that nature to adjust the tolerances if you need to as well.
Interesting. The experience I've got with coatings is more of these plasma, art gases, spraying these rather thick ceramic metallic coatings. So it's a little bit of a different world there from what I've come from. So you've got to maintain all these tight tolerances. What are the applications of some of these parts? What are they being used for? Why is it so vital for it to, I guess, have some of these different requirements?
I don't know if I want to know.
Yeah, absolutely. Well, for auto industry, especially when you're talking about tight tolerance, it usually comes in under the hood components or safety components. Seatbelts is a big one. So all the gear components in your seatbelt, you'd think most of those parts are metal, when in actuality it's mostly plastic.
Really?
There's key components that are metal within that help the seatbelt lock up and things of that nature. But all the gears inside of the seatbelt that makes it retract and lock up, most of those components are actually plastic.
That's fascinating. I know with metals, there's all sorts of different properties you can get out of the metal from the hardness, the tensile strength, bend strength, all of that. So I'm assuming the same's true of plastics there then.
Yeah, absolutely. There's and just like you have different alloys of metal, you have different compounds of many different resins. It's too many to count. You can go on like UL Prospector and Matt Webb and look up just plastics, and you'll see a list of everyone who's got their own different blends of polypropylene to acetals and things of that nature, and they all do different things. Just depends on your application and the properties that you need. What mechanical properties you do need helps drive towards what resin you use.
What type? If you're going to produce some new product, like what type of design process do you have to make all these decisions and determinations? There's a lot that goes into it.
Yeah, that's something that we try to stay away from. To tell you the truth, we are, with Millennium Plastics, and we're a tier 2 molder. So to put that in a little bit more layman's terms for the audience, the OEMs like Ford and GM and Chrysler and Toyota and all the major car companies are considered the OEM, right? Then you have tier 1 suppliers, which will, in most cases, supply large chunks of the large assemblies that go into the vehicle. And then you get down to tier 2 suppliers, which is what Millennium Plastics is, where we're molding a lot of singular components or very small assemblies that go to tier 1 suppliers. And then they assemble those components to send on to the OEMs. Tier 1 suppliers are, generally speaking, design responsible, and then they outsource the injection molded components to tier 2 suppliers and say, hey, this is our blueprint. These are the tolerances we need you to hit. You guys are the injection molding experts. We want you guys to make these parts for us. So we're given a design. We're given limited input to, hey, we'd be able to build a tool much cheaper or make a part that's way more robust if you can implement these design changes for us. Or if you use this material instead of that material, it's a little bit easier and more robust and things of that nature. So we try to limit our design responsibility to specific to injection molding from that perspective, just because that's where we're the experts in. We're not the experts in designing and functioning vehicles.
No, it makes sense. Makes a lot of sense.
Do you know where all your items go? Like which cars they go on?
Sometimes we don't get that information. We can get some of that, and it's one of the tough things about the auto industry is, and especially when you're talking about ISO certifications like ISO 9001, where you're responsible for your quality and understanding what your parts do, and you're supposed to get design FEMAs from the OEMs, but you never get design FEMAs. So you can ask 1,000 times and 1,000 questions about it, and sometimes you get all the answers, and sometimes you don't. So it's a little bit of a crapshoot to get the information of what vehicle and what platform they actually go in. It's unfortunately the name of the game.
Well, I mean, if you've got a very clear tiered structure, then the responsibility falls to one or the other, and you're just responsible for the requirements you give in there. You mentioned that y'all might be doing other work for folks outside of the automotive industry. You mentioned medical. Tell me a little bit about that. That's something that's a bit of interest to us these days as well.
Yeah, it's a different world. There's a lot more. I guess I shouldn't really say there's a lot more requirements. It's a lot of very similar requirements, just in a different fashion, right? Because it's a different certification for auto versus medical. Medical is really, really difficult to get into, and to achieve, high volume status for some of that stuff, it's a little bit tougher game. So I have some colleagues that are in the medical business specifically, and they have clean rooms. They do, the whole 9 yards there. And wow. It's not really something we actively go after. It's something that we keep in mind that, like, hey, if there's this opportunity that's really high volume and it's not a full-blown clean room, and it's, right, there's certain stages of clean rooms. If it's not a full-blown clean room, it's really high volume and it makes sense for what we do, we'll entertain it. But outside of that, our main focus really is in automotive and industrial and non-clean room initiative type components.
No, that's neat. I think this is all the more interesting because, we're in Houston. So I think the majority of the guests we've had have been talking about things related to the oil and gas world. So this is definitely a little bit of a different world than what probably a lot of our listeners are actually accustomed to listening to on here.
So with that, I'm going to ask, what is a clean room?
Yeah, so medical molding, there's various stages, and you'll have to forgive me, I'm not an expert in it. But generally speaking, a clean room, if you get into real high level clean rooms, you're wearing a full gown, you're wearing hairnets, you're wearing shoes that are specific only to that clean room. And a lot of times, depending on the state of the clean room, you'll have a gowning room, so to speak, that has filtered air and it's regulated temperature and humidity in there. The clothes that you wear into the clean room are only in this gowning room that never leave the gowning room at that point. And it's all about decreasing any sort of contamination or particulates that could be in the air from the outside getting to the inside into the molding process. Parts that,
so you'll have to do that. I'm sorry. You'll have to do that for the molding process.
Yeah. So the molding itself will take place in a clean room, which,
wow.
which essentially, like I said, you're in a full gown. You're exchanging your shoes in this gowning room to be shoes that never leave the clean room, so to speak. You're walking on these mat pads that are tacky and sticky to collect any kind of particulates or debris off of your shoes before you walk in. You generally have to sanitize and wash your hands before you enter the clean room. Before you can actually get to work in there, if that's where, if it requires a person in the room to actually be present and start up a press or whatever. But that's high level, and I'm sure they even go higher level than that. And I'm probably oversimplifying really what it actually is still. So,
well, you can only get so detailed in 20 minutes.
Well,
anyways.
and I can understand why you guys don't want to get too involved in that. That's a lot to go through.
Yeah, and it's very high regulated. So there's testing that has to take place on a regular basis to ensure like the air filtration is correct and the temperature is correct and all that good stuff. And if God forbid something happens or you have a maintenance failure and you're not controlling the temperature, humidity, or the air filtration in some form or fashion, there's a lot of extra steps involved to being, recertified that the clean room's intact, I guess, so to speak. It's a different world. It's not a world or a sandbox that I really want to play in for Millennium Plastics.
So for folks that aren't familiar with anything in the automotive industry, we've talked about, ISO 9001, but what are other certifications that you guys have to maintain or that are common to the industry?
That's the big one, is ISO 9001. Essentially, to be in the automotive industry and supply to a tier 1, you have to have ISO 9001. Otherwise, you'll never get any business. The second stage of that is IATF 16949, which is supplemental to ISO 9001. Essentially, IATF 16949, all the years ago, it used to be called TS 16949.
Right.
And all the automotive, the big wigs in the automotive got together and said ISO 9001 is great, but we need to take it to the next level, so to speak. And they added this TS 16949. That recently morphed into IATF 16949, which essentially takes the ISO 9001 and puts it on steroids and adds a bunch of other requirements for molders to meet.
That's
good news
the,
for
that's
go
the
ahead.
exact same. Describe the API standards for the oil and gas world. Is you can take the API Q1 and Q2 specs, and that's it. It's their 9001 on steroids. And for years, they actually took the exact language of the 9001 standard and then just added a few more thou shalls to each clause.
Yeah, and that's pretty much what the IATF 16949 is. It just takes everything that's in ISO and then adds a lot more requirements. And it's really geared heavily towards recording and reporting than anything else, just to make sure everyone's keeping track and has good record keeping of everything. But that's really just what it is. It's the ISO 9001 on steroids. But those are really the main two. If you don't have at least ISO 9001, you're not going to get business as a tier 2 supplier. And to do work with an OEM, you have to be IATF 16949 certified in most cases.
Makes sense. Now, you talk about records with the number of parts y'all are producing. I can only imagine the number of inspections that you conduct and non-conformances to record are just sometimes astronomical. Tell me a little bit about what that inspection and record keeping process looks like.
Well, so that's where Millennium Plastics kind of shines compared to most molders. I think you could say, where we're not really inspecting a heck of a lot. We're producing millions of parts, and we're checking a few parts per shift. So a few times a day we're checking parts, and that's it. The reason we're able to do that is all the controls we have in place in the actual molding process itself. So what's unique about injection molding as opposed to maybe some other industries where you're forming product is I can control the injection molding process very finely using technology that's available to us within the molding machine and auxiliary equipment, that I can ensure part dimensions and part integrity by machine tolerances. So I can ensure that the same amount of plastic is going into that mold every time. I can ensure that it's going at the same speed every time, at the same temperature. And if it doesn't, the machines will automatically reject those parts. And I can correlate that using capability studies on the machine, the equipment, and the parts to prove to customers that, hey, if I just check this one dimension every 8 hours and the machine stays within these tolerances, all those parts are exactly the same. And that's something that we do early on in the process and process development to show proof to our customers that we don't need to check a part every hour, because these machine parameters, once you see they go out, that's when you start to see dimension and tolerance issues.
Very, very smart. I got to tell you, I've worked with one other organization that does injection molding before for plastics. And, I think they had a team of 25 inspectors that they did all day, every day is just nonstop inspecting and checking. I think they'd spend 3-4 hours a day just going through paperwork. So it's fascinating.
It's actually one of the things that we have to struggle with a little bit, because IATF and OEMs are so big on having that data to show that you're within print, like actual part data, when the machine data can tell you whether or not you're going to be to print on a part or not. A lot of times it's a struggle for us to convince our clients that we can prove that with the machine capabilities that we have, that we're able to provide a part that's to print and not have to provide you 100 checks per day, where we can do the same thing with only 5 checks per day. It's a struggle.
I bet. Mm-hmm. I bet. But it's just really, really amazing that you're able to do that. That's something I think a lot of folks could stand to learn from. It's maybe this will be the last point here, because we're already going a little over time. But what's that process look like when you set it up? So when you set up a new machine, you set up this new process, how do you go about making sure that you know those requirements so that you can be so confident?
Boy, you could probably do a whole podcast just on that question alone.
Maybe that's what we'll do then. We'll record another episode to air here at a later time, and we'll discuss those details.
Yeah, I'd be happy to. Simply put, there's specific parameters on an injection molding process that you monitor and check. And there's a certain process that we go involved that I won't divulge too much information, because it's a little bit of our secret sauce on how we can do that. But really comes down to doing a lot of capability studies on your machine and equipment and monitoring the right process parameters to be able to prove that stuff out.
Well, then we will definitely have you back on here soon. And so for our listeners, be keeping an eye out for that next episode, because I think that's going to be a lot of fun to talk about.
Yeah, I'd be happy to. That'd be great.
Well, hey, I appreciate you taking the time this morning. And this is something it's a little different from what we usually do, but just really fascinating information. We talk all the time about how, quality is really quality across these industries. And I think you made the point with the medical devices. It's the same idea. It's just a little different angle to go from it. And you're seeing the same thing with automotive versus the oil and gas world. So it's really fascinating.
Yeah.
All right.
Thank you for your time, Adam.
Yeah, thanks. I was happy to be here.
Hey guys, this is Darcy with Quality Matters. We really appreciate you listening, and if you enjoy it, we invite you to subscribe. You can find us on iTunes, Spotify, anywhere you listen to your podcast. Subscribe, comment, leave us a review. We're happy to hear from you.